We're now in section 4, the final section, where we will create a time series chart of monthly precipitation. So far, we have started with our CHUBS collection, pentad collection. We have aggregated it to monthly images for 1 year. And we now have a monthly collection of images. We have 12 images representing the total rainfall for each month at each pixel. Now we want to create a time series chart. So we need to first figure out a location. So we can choose a location. I'm going to choose the city of Bengaluru. We can drop a point. So I can just select a point and drop a point here. Okay, so it has created this import called geometry and with the lat long of that city. And now we want to create a chart representing the trend of monthly rainfall at this location. So let's create the chart. There are many charting functions provided by Earth Engine. They are all under UI.chart section. The functions are grouped by the type of object that you can plot. So if you were working with images, these are the different image charting functions. We have a time series plotting functions here. This is a UI.chart.image series, which will, given a location or a geometry, it's going to plot the trend of the values over that region. There's also a UI.chart.image series by region. That means you have multiple regions, you want to compare the trend between them, you can use that function. We're going to use this one since we want to plot at a single location. We can use this UI.chart.image series. One tip is you can also use control space in Earth Engine to auto-complete the function parameters. This is very helpful where you don't have to remember the order of each parameter. You can simply autofill and then supply a dictionary of those parameters instead of a positional arguments. So the collection that we want to plot is the monthly collection. The region that we want to plot the time series for is our geometry. This is the point that we plotted over. Here we are just using 1 point, so there is only going to be 1 pixel at that point. If we had a polygon instead of point, we can plot only 1 value on the y-axis. So maybe our polygon has 100 pixels, and at each time step there are 100 precipitation values. Which one do you want to plot? And that is specified by the reducer, which can just specify reducer mean. So if you had a polygon as a geometry, and if you want to plot a time series, it'll be the average rainfall inside that polygon. In the point, really doesn't matter, but we can still use that as a default. Scale. At what resolution do you want to chart this? This should always be the native resolution of the data. If you don't know what is the native resolution, each Earth Engine dataset specifies the resolution of each band in the dataset description page. So here we go to the CHUBS pentad. And if I go to the bands, it will say this is the resolution. So the resolution is 5566 meters. So we can take this and put this as the scale parameter. The scale has to be always in meters, regardless of whatever projection that you're using. We don't need to specify X property. X properties by default is the system current time start. Right, so we have a chart. Let's print it and take a look. And you can see we have a chart of the monthly rainfall series. I can pop this chart out to get a bigger version. And you can see now this is, if I hover over it, this is an interactive chart. Say in the month of May, this was the 138 millimeters of rainfall that month. And you can see the trend. And this is much more useful. If I had plotted a pentad time series, it's not easily interpretable. Nobody really cares about how much it rained in every 5 days. But monthly rainfall is something useful. This is the city of Bengaluru in south of India. There are 2 kind of rainy seasons. There is an early monsoon showers around April. So you see a peak rainfall here, and then the main rainfall season starts around September, July, goes all the way till October, and you can see this in your time series chart here. The default charts are okay, but they are not something that you would write home about. It's not something you would include in your publication or in your presentation, so we need to make it look a little better. The way to make your charts do better is each charting function has this method called set options. Set options allow you to provide a dictionary of different styling options that will make the chart better. I'll explain some of those options. There are many of the options. They are all coming from the Google Charts API. And if you want to know more about that, you can go to Google Charts and documentation and see what those parameters are. Let's first customize our axis and title. So I'll just set a title to be monthly rainfall. And I'm going to just set back. Yeah. Let me run this and you'll see the chart update with the title. Okay, so I've now updated the chart here. Let's change the vertical axis instead of in the y-axis, instead of making it a mean, we'll just say v-axis, and the title of the v-axis has to be rainfall in millimeters. H-axis, again, you can give it many different parameters, so that's why it's a dictionary. And this will be month. Let's run this and see the results. So now you can see my x-axis is labeled as month, y-axis is rainfall millimeters. We can make our time series look a little better. I'm going to add some options here. I'm going to say point size is 3. So each value, there's a dot. You can say the size of the dot is 3, and then we can set the line width to be a little smaller, to be 1. And you'll see what that does to the chart. You can see now my lines are thinner and I have a dot at every data point. And this looks like a pretty good chart. I can pop it out, take a look. If I like it, I can download the PNG, save it, and include that in my presentation. There are many more options that you can explore under the chart options. These are infinitely customizable. So if you want to change the color of the axis, or color of the lines, if you want to have a different legend, if you want to customize the grid and so on, there are parameters to adjust for all of those. But for now, we have a pretty decent looking chart that we generated out of the original Pentart collection. Thank you. That's the end of the chapter. If you want to learn more resources, I have linked to some additional resources in the slide deck. The slide deck will be available in the video description. There is one video series on how to take this to the next step, where you want to now aggregate it to monthly time series over multiple years. So we need to map another function that aggregates this over a year. And if you want to learn that, I have a video series as well as open code on doing this. And if you want to do trend analysis on whether the rainfall has been increasing, decreasing, and get a statistical measure of this, I have a full course material along with the code on this link. So you can learn from that. Thank you.